here we go. The first real episode of Kit Crashing. We wanted to create something for the Lunar New Year, or the Chinese New Year. What better thing to use than a dragon? So my thinking was that this dragon would be very abstract and sort of have a kind of ribbon-like quality to it. And I started to think about our Slab Tool that allows you to give thickness to sort of a flat area, or well, an area that's projected to some sort of topography. And then I was thinking about some new applications that we've been applying to environments to use a formula to show how you can manipulate values according to an equation, which is kind of neat. And so I was imagining this rippling equation, essentially, that would describe the dragon's shape. And the thickness is described by a few different layers of topography. Area shapes are defined by the areas that LandKit uses. So let's have a look and see how that all worked and came together. We started with a sketch. The sketch was done in an app called Paper on the iPad, and I love to do all kinds of stuff on paper because I can organize everything in notebooks, but this was a pretty basic sketch. The sketch, once it was done, I traced over that with curves and here in Rhino 8. If I just turn off this background, so you can see that I traced out each curve, and most often I would use the interpolated curve tool to trace, and I would always draw one curve on each side in order to get a really pointy end to either portion of the curve. Now, some of these are overlapping, and we're going to address that using the three-dimensional aspect of this setup. How did we turn this 2D drawing, which was done fairly quickly, into a three-dimensional form? Well, we jumped into Grasshopper and utilized LandKit. If we look at Grasshopper here, we can see that we have a few different pieces. Now, I'm just going to zoom in here and talk about what this thing is, and then I'll go into the detail. First, we start by creating a bit of topography. And then we use that topography to create an environment. We transform that environment in a special way, which we'll talk about. And we transform that in a couple different iterations. We define the areas of the dragon and pull out different area types. And each of those types gets transformed by different three-dimensional environments. We project the areas to the topography to make slabs. And then we bake them into the scene. And then there was a final little piece at the end, which I'll talk about in a second. The first thing we want to do is create areas using these curves. So if I preview that, I can see that I have those curves. And it looks like I have my 3D dragon previewed as well here. I will get to sort of how we got that three-dimensional quality in a few minutes. But if I hide that, then I can say, since all of these areas are created using the layer and color and geometry, each one has that data connected. So I can pull each layer out by a name. So here I'm using the red name because those are all going to exist at a different level. All of the, see, the red is all sitting up above the rest of the dragon. And then I pull the body and push that down below. It's at a lower level. So we're going to transform each of those individually. If we look now at how did we create the three-dimensional aspects of this? Well, I used two main components. One is Topo, or topography, to really push and pull that topography up and down. So some of that topography manipulation was done using environments, and a new trick that we have, which is called layer by formula. Effectively, what we did is we created, let me just preview. Actually, I'll use contours to show this contour.
mesh, and then I'll do every 20 units because this is a rather large thing. Let me do 10. You can see that the contours are it's just an elevation that's flat, and it doesn't actually undulate the way the dragon ultimately ends up undulating. And so in order to get that curviness of the dragon feeling like it's sort of moving up and down, as well as this sort of curviness in plan, I used an equation. So we have this initial topography, which is created using a base plane, some resampling and smoothing, some sculpting using a center line, and then some more smoothing. And that creates our base topography, which we just looked at. I use that topography to create an environment. I then add an elevation layer to that environment, as well as a proximity layer. The proximity layer has a single point at the head of the dragon. And that means that every point in that environment is essentially showing the distance away from that one point. Now, I can take the data from the proximity and the elevation and use that to transform the data in a new way using an equation. I want to change the elevation, so I say elevation is equal to 20 times the cosine of the proximity divided by 100 plus the elevation. Now let's break it down. The cosine is the main function here. We are creating a wave, right? A wave that emanates out from the point because we're doing the cosine of the proximity. If we divide by 100, that makes the wave 100 times bigger. If we multiply by 20, that makes the wave 20 units tall. And then we add elevation to make sure that we keep that mounding that we had here on the dragon's back. Then once we've done that, what will happen is that elevation layer within the environment will get changed out for a new set of values. And then we do the same thing. We make another small modification using another wave function. And then here we simply change the elevation by shifting it 15 units. Pretty simple. But the cool thing is we have 3 versions of the environment. One that we end up using for the red whiskers and ears, and one that we use for the gold body, and then one that we use for everything else. The red whiskers one, we've added a bit of its own wave function. Let's preview that and see what that looks like. There we go. So we can see that has a wiggliness to it, and we wanted that to sort of create the sense of rippling, these things rippling in the wind. And this is a little blocky, but we knew that we would be smoothing things down, so we didn't have a super high level of fidelity in the environment. I think the environment is at 40 units per cell size. Just a couple more pieces here. We take that mesh or any one of these meshes, and then we transform them down about 10 units in order to create a secondary layer. So we have our top topo and our bottom topo, and then the shape we've pulled out, the area. This tool, the draw areas as slabs, projects that area to each layer and creates a thick form that we ultimately see in the dragon's final form. Now, I did this and I thought it looked a little like it needed something else. One of the things that's so cool about dragons is scales. So I set up another piece here where I took the dragon's, the gold part of the dragon, the body part, and I used our new land kit add pattern, or a path pattern. That creates, here, let me preview that. That creates a set of paving running along a curve. We used the center line, the same center line that we used to generate the mounding on the back of the dragon to generate these pavers. Then I did some trimming. I had to simplify the border curve using the polyline. We do have a trim tool for pavers, which does work well, but it's in the middle of some repair work. So it's like, it's in the shop right now. But what's funny too is you can see how fast it is. It's actually much faster than the Grasshopper operation, which is pretty fascinating. I cannot believe this is working. Yeah, then we turn that into actually into a sub D after we project it to the dragon's back. And it creates such a cool effect. The next thing we did with this is we moved into Blender, partly because I was having some issues with the ray tracing in Rhino 8, and I'm not sure what that was about, and perhaps that would get fixed as well on trying again. In Blender, I was able to change materials and set up some cameras. I rendered each view, and we used those for our social media posts. But the last piece that I did was to take the model and export USDZ files. Now, USDZ is a new format that Rhino 8 can export. And if you've ever seen Apple's AR kit, you would know that a USDZ file is the file type that you use to preview things. So like I could send somebody a text of a USDZ file and they could preview it on their phone and sort of see it on a table and kind of move around it. Well, that technology has come to the Vision Pro and arguably was probably created with the Vision Pro in mind, since Apple knew about this for so long. But I was able to view this in my own studio. Once I got the file lined up in my space, because when it first comes in, it's at an actual scale. I actually scaled it down by 100, but I did have to scale it a little bit more just by pinching and zooming. But once it was in my space, I was able to spin it around a little bit and move around. And I even dropped it for the next day up on my shelf with some of my other things. So that's Kit Crashing Episode 1. I hope you've enjoyed it. Please visit landkit.design for more information about Landkit. And I hope you look forward to more Kit Crashing episodes. Please subscribe, and we'll see you soon.